Hi everyone, we're back with some more videos on functions, and now we're going to talk about function notation. Now, everything you've encountered up to this point is some sort of equation involving one or two variables. For example, a line could be written, one particular line is y equals 3x plus 4. And from this equation point of view, this is a line. It has slope 3, and the y-intercept is 0, 4. So these numbers all have meaning. And so what's different about notation with functions? Well, a function will always start off with f of x. So this is the name of the function. And this is the variable, or the independent variable to be specific, because you can freely choose this to substitute this with any number in the domain. And you can name things whatever you like. We don't have to just use f. We'll see g of x. We will see later in the semester things like ln of x, log of x. And in future courses, you'll see other function names as well. So, for now, but standardly we just use f for function, and then if we need more names, we just come up with them. Usually we just go g, h, i, j, k. So, what do you do with a function? Well, a function is always equal to an algebraic expression. So, you can do things with functions that you can do with algebraic expressions. You can simplify. You can, let me write that a little neater. You can simplify. You can substitute for a variable. And those are kind of the two big things we're going to do right now. So let's look at an algebraic expression. F of x equals 3x plus 4, which is just my line written in a different notation. So, what does the function think about this? Well, from the function's point of view, from f's point of view, this is what we're doing. We're taking x and we're multiplied by 3 to get 3x, and then we're going to add 4 to get 3x plus 4. So this is all the function cares about, is what it does to the variable. So, but there is kind of equivalence between the two forms, and we often write y equals f of x. Because if we look at the graph of this function, or this equation, so we're going to be at here for the y-intercept, we're going to go up 3 and over 1 for another point. And so every point in this graph is some point x, y that satisfies y equals 3x plus 4. But we can also think of these as points x comma f of x, and we just write f of x equals 3x plus 4. So when you solve for y equals, you can either think of it as an equation, or you could think of it as a function. And the graphs are same, but you do different things. Here you solve for variables. But here you would substitute in values. values, and do simplifications if needed if it was something more complicated. But there's no solving involved for functions, typically. Because you could think of y equals f of x, you could always solve for the function like a variable as well. But that's a different topic for a different day. Other things you could do with equations, you can graph them. So notice that the graph of the equation is also the graph of the function, so there's no loss of generality. So you could just, even though you're given this, you could still graph it. You just think of it as an equation. So that's kind of how function notation works. And the next part we're going to focus on this part is substituting in values. And values don't necessarily also mean numbers, though that's the vast majority of the things we do, but it could also be algebraic expressions as well. And so we'll see how to handle both cases in the next video. So see you then.